so what you see up on the smartboard right now are the answers to your warm-up. I would like you to take a moment to check yourself, and as I look around, you guys did a really, really nice job. The smallest number that 4 and 5 go into is 20, so that's the LCM there. Smallest number that 6 and 15 go into is 30. Part C is 4x, D is x squared, E is x times the quantity of x plus 2, F is t times the quantity of t minus 3. Ooh, what's up? E and F, is that what you're asking me about? Okay, the first thing we always do when we find a common multiple or common denominator is you have to factor first. And I didn't show it. I saved this slideshow from a little earlier. I didn't show my factoring, but here's what I did. I factored a GCF out of this guy. And so you always start by factoring. That first x plus 2 didn't factor. So I wrote that down. Then I inserted factors that might be missing from the right. So I had to add on that factor of x there. And same thing with f. Okay, does anybody have any questions about that? Because we're going to do something today called the LCD method. And if you can't find the LCD method, very challenging. Very challenging. All right. So here's what you're getting from me today. You're getting not one, oh yeah, but 2 techniques for solving for x in a rational equation. Now, the tough part for my students oftentimes is deciding when to do what. Which technique should you use? Well, I'll go ahead and let you know that the lesson starts off with a very special type of rational equation. It's what we call a proportion. So as you look at the first example in today's lesson, ooh, geez, I wanted my blank slideshow, sorry. Blank one, okay. So as you look at today's lesson, what I'm going to tell you is that this right here is a proportion. That is a proportion. You don't have to circle that. You know what else is a proportion? That. That is what we call a proportion. You want to know what's not a proportion? That. That is not a proportion. You know what else is not a proportion? Yeah, that. Or the next one. So I have a very important question to ask you to help you nail that answer to the question, when do I do what? The when do I do what, the answer to that question lies within the type of problem you're dealing with. You use one method on proportions. The LCD method, you don't use on proportions. I guess you can, but it's long, you know. So long story short, my simple question is this. How can you tell the difference between things that are proportions, things that aren't? So I'm going to say it again. How can you tell the difference between things that aren't proportions versus things that are? So proportions, not proportions. You got some ideas? Not proportion, not proportion, not a proportion. Oh yeah, proportion. Proportion. Ooh, Helene, go ahead. Yes, perfect. In these problems, you see there's a real big plus sign hanging out in the problem. Those are categorically rational equations. But a very special type of rational equation occurs when we just have two ratios set equal to each other. Whenever you have a ratio, that's fancy talk for a fraction. Whenever you have a ratio set equal to another ratio, that's what we call a proportion. So fraction set equal to a fraction, fraction set equal to a fraction. Regardless of the type, you always have to check for extraneous solutions. You might recall extraneous solutions are solutions that do not work when you plug them back in to the original equation. So we do have to check our answers in today's lesson. All right, so let's do this. Example 1 has us solving a proportion. You did this a ton in geometry. Like whenever you had similar figures, if you were dilating a figure by a certain scale factor, or if you needed to find what a scale factor was in looking at two dilations or a dilated figure in its original, you were finding that scale factor sometimes by solving a proportion. And when we solve proportions, the major technique we use is cross products. Remember putting the little x on the equal sign? We're just reviewing that to start today's lesson. Cross product property says basically this: the product of the means is always equal to the product of the extremes. So the product of my means, x times x. I'm sorry, that's the product of my extremes. Product of the means will be 4 times 4. So after you set up your cross product, you actually have to, multiply. So x times x is x squared. And then 4 times 4, that's 16. We then need to solve this equation for x. So how do I get that x by itself, Tammy? Square root. Remember that whenever we square root both sides in this fashion, there's actually 2 values for x that would satisfy the equation, right? There's actually 2 numbers you could square and get 16. What are they? 4 and negative 4. Nice. So we usually just say that as plus or minus 4. Get 2 answers. And now we check it, right? I always check it by copying down the original equation. And then wherever there's an x, I leave a blank. So the original equation says x over 4. I'll write that down as blank over 4. And then that's supposed to be equal to 4 over blank. I'm now going to use my property of substitution to check. I'm going to check first the answer of x equals 4. So wherever I see an x, I'm going to put in my answer of 4 that I calculated out. And I'm going to see if I generated a true statement. Well, I know that 4 over 4 equates to 1. Oh yeah, and 4 over 4 on the right side also equates to 1. So that guy works. I also need to check negative 4 to make sure that that is a solution that works in my original problem. So I copy down the original problem, and wherever there's an x, I put a blank. And now I'm going to check my answer of negative 4. So I plug negative 4 into my original equation. The value of a positive divided by a negative yields a negative quotient. So I get negative 1 on the left side and a negative 1 on the right side. And that's also a true statement. So I know that my 2 answers for this equation are positive 4 and negative 4. Part B is also a proportion. I have one ratio set equal to another. The technique we're studying to solve, though you could use the LCD method that I'll show you in a couple minutes on every problem, the easiest way to solve this style of problem, in my personal opinion, is cross products. So, product of the extremes equals the product of the means. So I'll take 2 times 5 equal to x minus 5 times x plus 4. After you set up your cross product, you have to multiply. So I'm going to multiply. 2 times 5 is 10. Remember, to find the product of 2 binomials, we just FOIL. So I'm going to do x times x, that's x squared. The outers is going to be 4 times x, or 4x. The inners is going to be negative 5 times x, that's negative 5x. And then my lasts multiply together to yield a product of negative 20. I'll combine like terms. And then I really can't solve something of degree 2, aka a quadratic. Oh my. I can't solve that unless one side is equal to 0. So I am going to get one side equal to 0 by subtracting 10 from both sides. in subtracting 10 from both sides. My left side is now 0. And I have something on the right side now that's very factorable. So factors of negative 30 that make negative 1 in between. I'm thinking that's negative 6 and positive 5, yeah? So that's just going to be x minus 6 times x plus 5. Lastly, we use our zero product property. If we have two things multiplied together to equal 0, one of those two things, or both, must actually be 0. So that gives me two linear equations to go ahead and solve. I'll add 6 to both sides, 5 from both sides on the other, and I get my two answers. Just so that I have plenty of time to do the tougher method today, I'll go ahead and let you know that both of these methods work. Both of these answers work, I should say. Okay, questions on how to solve a proportion. Your assignment for tonight has you just addressing proportions. And then I'm going to do a little bit more guided practice with you tomorrow with regards to the second method you're going to see. And then we'll practice that as well tomorrow. So you won't see any of this second method on tonight's assignment, which is good because we're on Skeleton Crew right now here in A101. A little attendance. Dropping attendance for today. All right, so key point 2. So key point 2 went through the wash, nice and crispy. Key point 2, using common multiples. Some of the rational equations can't be solved using cross products because they're not proportions. In this case, what we could do is multiply both sides of the equation by the LCM. Oh, I have a cold. It's messing me up. Okay, we actually did this method before. You can put your pencil down. This is purely for your visual entertainment. You did this method that I'm about to show you, but we did it in, I kid you not, like September. But we did it with really smaller fractions. So let's say, for instance, you had an equation like 1/5 x, plus 1/6 equals 8. And you look at that equation and you're like, oh man, like you got to subtract 1/6 from both sides, get a common denominator there. Work that out, and then you have 1/5 x, so you got to multiply by the reciprocal, and it's a lot of work. So I taught you a shortcut at the beginning of the year. Okay, throwing it out there. It was a long time ago, but does anybody remember what that shortcut is? You kind of do. Let me get it started and see if you can tell me what I would do next. How about that? So my eyes automatically go to all of the denominators in the fraction. And I try to find the least common multiple. That's why you had that warm up today. You have to find the least common multiple of all of those denominators. So in this case, it'd be 30. Yeah, very good. You just multiply 30 all the way into the problem. Very good. You just multiply it on the tops even. Very good. So when you do that, 1/5 of 30 is 6. 1/6 of 30 is 5. And then, 8 times 30 is 240. So you get this much easier equation to solve, just by multiplying by the LCM. Do you remember this? I think Eddie does. Yeah, obviously he contributed, but does that ring a bell a little bit? No? Okay. Some of you yes, some of you no. Well, keep in mind that the idea in the method, moral of the story, is that if you don't like the fractions, you can just get rid of them. And that's what we're going to do to solve these bigger equations today. So back to our slide here. You see that you have a messier equation that has some fractions in it. And what we're going to do is we're going to get rid of those fractions that are in the problem. This is, in essence, your LCM method. You'll see that I typed out the 3 steps. So you just kind of need to jot it down as we move forward. You can pick your pencil back up. And in step 1, you want to identify that least common multiple of all of the denominators in the problem. So I need to identify right now the least common multiple of 5, x minus 3, and 1. Because that's all of the denominators in the problem. Step 1 in identifying your LCM is to factor, but that's not necessary for this problem because they're already factored. You bring down what you see on the left and insert factors that might be missing from the right. So I have to insert that missing factor of x minus 3. And then you could insert that missing factor of 1 if you wanted to. However, multiplying by 1 doesn't really do anything because it's the multiplicative identity. Okay, so step 1, done. We found the LCM. Does anybody have any questions with step 1 before I go on to step 2? Okay, so step 2, we put this LCM outside of our problem in a big box. So essentially what we're going to end up doing in this step is multiply the LCM into both sides of the equation. So here's how that looks. You take your equation, you put it in a box. And we're going to distribute that LCM that we calculated in the first step into the entire problem. Please recall, as Eddie said, you know, in the previous part, he's like, oh, you just put the 30 on the tops of everything. That is indeed true. And it's indeed true because we could think of, you know, 5 times x minus 3 as 5 times x minus 3 over 1. So we distribute through the top and you distribute through the bottom. That is for sure true because that's how you multiply fractions. You multiply straight across. However, when you multiply by 1, the denominators never change. So in my next little chunk over there, you're going to see that only the numerators change in this distribution. So here's how that looks. So 3/5 goes from just being plain old 3/5 to 3 times 5 times x minus 3. Because again, I'm doing that distributive property. And then I'm doing 1 times 5 on the bottom. So that's just 5. Bring down my plus. And then I have to distribute that 5 times x minus 3 to the 4. Oops. So this is 4 times 5 times x minus 3. And then that is over 1 times x minus 3, which just stays x minus 3. And then that's equal to 7. It was 7 over 1. I have to distribute that 7 to the LCM rather, that 5 times x minus 3 to the other side of the equal sign also. So it goes to the whole problem. Multiply both sides by the LCM. So indeed, the numerator is the only thing that kind of changes in this step. Here comes my favorite part. Do you see what I see? Things cancel. You see it? Yeah. So like in the first fraction, yeah, your 5s go away. In your second fraction, your x minus 3s go away. On the right side, there was no denominator really. I mean, 1, but division by 1 doesn't really do anything, so that just stays. I usually go ahead and circle what I have left over so that I can go into step 3. In step 3, I'm going to solve with what's left over. So here I have 3 times x minus 3 plus 4 times 5 equals all of that. Seven times 5 times the quantity of x minus 3. So now when I go to solve, you know that the first thing we got to do is we got to simplify both sides of that equal sign a little bit. when we simplify, what I mean by that is you're going to use your distributive property and combining like terms to kind of, you know, make both sides of the equal sign a little bit easier to work with. So distribute my 3 in, multiply 4 times 5. 7 times 5 is 35. Bring down my x minus 3. I then combine like terms. So I have 3x, negative 9 and 20 is 11. And that'll be 35x minus 105. I usually move all my variables to one side and constants to the other. So I'm going to subtract 3x from both sides to move all of my variables to one side. And then I would add 105 to both sides to bring my constants to the other side. So you get 116 equals 32x. Divide both sides by 32. You get what, 29 over 8. Remember that it's important to check your solutions. For the sake of just practicing the method a little bit more before you leave me today, I'm going to go ahead and let you know that this one works. I also kind of have like a shortcut way that you can check your solution. I'll show you that in the next example. Yes, John? No, you can have 3.625. If I were going back through and checking this solution, I probably would use my calculator a little bit to make it faster. Any other questions? No? Okay. So, one more time all together now. And then you have one conclusion question to wrap up with. Make sure you can do it one time all by yourself before you leave. In example 3, the first thing I do, my eyes go to the denominators right away, because I know I have to find at least an LCM to use the LCM method. Can't use the method unless you identify that common multiple. What's nice about these denominators is that they're already factored. So I don't have to do that part. It's nice. So I'll go ahead and identify the LCM. LCM of all of the denominators in the problem. So I bring down the denominator that's furthest to the left. Compare it with the factor on the right, and I didn't write d minus 2 yet. I need that. And then when I compare this with the denominator furthest to the right, I have d minus 2d plus 2. And so I don't need any more factors. That's my LCM. It's all done. Okay, so I've identified my least common multiple. Now I'm going to use this to get rid of all of the denominators in the problem. I do that essentially by multiplying both sides by the LCM. So what we're going to go ahead and do is take our original problem, and I put it in a box because eventually I'm going to distribute that LCM to the whole problem in there, in that box. And do the distributive property without your quantity there. And what I'm going to do is bring down that LCM. And essentially in this step we're asked to multiply that LCM by both sides of the equation, or onto both sides of the equation. So here's me doing that. Remember, this LCM is over 1, so I distribute 1 through the bottom of my fraction, which doesn't really change your denominator at all. When you do this distributive property, when you execute that property, the only thing that really changes again is the numerator. So I'll write down my problem here, and you're going to see the numerators change. I'm going to distribute that d plus 2d minus 2 to every single top. And keep in mind that the idea in doing so is to get the denominators to cancel. So as you write this step down, kind of keep in mind that things should be falling off of your problem. If you don't see things that are going to cancel when you do this step, chances are you found the wrong LCD. So you probably go back and take a look at it again. It's step 1. Okay, now, my favorite part, you get to cancel. Anybody tell me what cancels in that first fraction there? Good, Tessa. Second fraction? D minus 2. Notice the denominators are what always disappears. That's the idea of this method. The denominators go away. And then, oh, this one's awesome. Do you see what cancels? Yeah. And then I usually circle what I have left over because in step 3 I have to solve an equation with my leftovers. So in my first fraction, my first ratio there, my first rational expression, I see I have d times d minus 2. Remember those slashes always turn into 1s, so that's why it's just d times d minus 2. Like times 1, you know. Bring down my plus. And then in my second ratio, I have 2 times d plus 2. And then that is equal to d plus 6. So now I have to solve this equation for d. Remember when you go to start this step, you're thinking distributive property, combine like terms. So in an effort to simplify each side of the equal sign a little bit. So I'm going to distribute. I would then combine my like terms. And you really can't solve a quadratic unless one side is equal to 0. So I'm going to subtract d and subtract 6 from both sides. And then I get a really factorable quadratic. Factors of -2 that make -1 are -2 and +1. And then I have 2 quantities multiplied together to equal 0. So I have to use my zero product property to solve. Set each piece equal to 0. On the left side, I'm going to add 2 to both sides. And on the right side of this problem, I'll subtract 1 from both sides. And those are your 2 answers that we could actually think about making a true statement in the original equation. Remember, you always have to check. I'm going to go ahead and let you know at this point in time that one of those answers is extraneous. One of those answers does not work when you plug it back into the original equation. So here comes your shortcut. You ready? You're going to love it. At the very beginning of the chapter, I made you do domain of a variable. We talked about it for 3 types of functions: polynomial, radical, and, oh yeah, rational. Remember, for a rational function, there's a rule that you have to follow with regard to the domain. Does anybody remember that rule? Back to your test. Back, in a rational function, you had to identify its domain. What'd you do at the bottom of that fraction? Oh, no. You can't divide by 0, right? No, can't divide by 0. So the bottom of the fraction is never allowed to be 0. So 2 doesn't work. Very good. Yay. That answer right there makes a denominator in the original equation equal 0. And we can't have that. Nobody can divide by 0. It's undefined. So the answer to this problem is -1. questions about that? All right, you have one to do all by yourself. And then that'll wrap up our lesson for today.